All right, kids, here we are again. So we're going to start with our properties of exponents. So this is review packet 3. Put that here because I scrolled up too far. Review packet number 3, topic 1. So we're going to go ahead and write our rules up here, and then we're going to do some practice problems on this page. We did this at, oh gosh, way in the beginning of the year, and I think we had started reviewing this for LEAP before we got out of school, but to be honest, I can't remember. So the product rule, when you're multiplying powers of the same base, you add those exponents. So it's going to be ax to the a plus b. So the opposite of that is when you are dividing powers of the same base, we're going to do the opposite operation. So x to the a divided by, that's the division bar, x to the b equals x to the a minus b. And then the power rule, when you have a power, which is a base and an exponent, and then you have it raised to another power outside of parentheses. Remember we said it was similar to distributive property with exponents. It's going to be x. Yes, ma'am. Hang on just one sec, Mama. All right, so we're going to have a times b, because when you're multiplying, when you're raising this power to another power, you multiply those exponents. Okay, so we either add, subtract, or multiply. So on this one, we have x to the second times x to the, that's an 8, it looks like on mine. So it's going to be x to the 2 plus 8, which equals x to the 10. All right, so on this one, now look, this is a little bit different because we have a negative 2 and a 7 there. So if we think, you don't have to rewrite it this way, but let's show how our thinking should be. So we're going to have negative 2. We're just going to reorder it times 7 times m to the 8 times m to the first. Remember, there's a 1 right here if they're not showing it. So then you can see here that we're going to multiply the coefficients together. So we're going to have negative 14 times m to the 8 plus 1, which equals negative 14 times m to the 9. All right, that's a 9. Okay, so again, we'll practice one more with this one. So we're going to rewrite it as 6 times 2 times a to the 3 plus 4. If you'll notice, all I did was combine these two exponents, times b to the 2 plus 3. Again, all I did was add these exponents because we're multiplying powers of the same base. So 6 times 2 is 12 times a to the 7th, b to the 5th. All right, we'll do one more right here, because if you'll notice in our instructions, it said your final answer should have positive exponents only. Okay, so again, we're still multiplying powers of the same base, which means we are going to add these exponents. So we end up with k to the negative 1 plus a negative 4. Well, negative 1 plus negative 4 is negative 5, so we have k to the negative 5. But if you remember, this doesn't make the answer negative. Remember, we find the reciprocal of the base, and so this becomes 1 over k to the 5th. Remember, if you have a negative exponent, you find the reciprocal of the base, and that makes the exponent positive. All right, so let's look over here at this one. And so we're going to rearrange it again because we're going to show how our thinking is going to look. 4 times negative 7, and I'm only putting it in parentheses so I don't have these two symbols next to each other that causes confusion. And then I'm going to have times p to the negative 5 plus 9. Notice I just added these exponents. And then times q to the negative 2 plus 1. Again, I just added these exponents. If you're noticing, there isn't one here. So we understand that if it's not written, it's understood to be 1. All right, well, that makes it easy. So 4 times negative 7 is negative 28 times p negative 5 plus 9 is positive 4 times q to the negative 2 plus 1 is negative 1. So you should be immediately noticing, oh my God. All right, again, I forgot to unpause my screen sharing. So I don't know where we were. So let's go to this one. We added our exponents, and then notice we had a negative exponent here. Just so you remember what I just said. I know you could hear me, but you couldn't see it. So we found the reciprocal of the base. And then we worked on this one, and we did everything we've been doing, combining our exponents, multiplying the coefficients. But now, okay, now that you can see it, for heaven's sakes, I'm having issues. All right, but we have a negative 1 here. So we're going to have to simplify that. So we have negative 28 p to the 4th. That's at the top. And now we have to put this q, because it has a negative exponent, it becomes in our denominator over q, because it becomes 1 over q because of that negative exponent. All right, so pause if you need to make sure you write all that down. I've got to erase all this so that I can scroll up. Okay. All right, this gives us enough to work with. So those were all multiplying problems. We're now going to look at this one because it's a division problem. You can see that division bar right there. So this is going to be in, remember we subtract the exponents, so it's going to be 20 minus 5. So that becomes n to the 15th, because 20 minus 5 is 15. So we're going to skip right on over to this one because it's got these negative exponents here. If you remember from class, we always did them separately. So we end up with c, now remember we're subtracting these, c to the negative 9 minus negative 2 times d to the 3 minus 11. This is really important, putting that in parentheses, minus negative 2. If you look at the top of your page, it says when you divide powers of the same base, you subtract the exponents. So it's not just negative 9 minus 2, it's negative 9 minus a negative 2. That makes all the difference. So now our answer is going to be C, negative 9 minus the negative, if you recall, is plus. Plus 2 is negative 7. And then D, 3 minus 11 is negative 8. All right. You might think we're finished, but of course we're not, because we have to make our positive exponents, which means we have to find the reciprocal of both of these. It's going to be 1 over c to the 7th times 1 over d to the 8th, which makes it 1 times 1 is 1, c to the 7th, d to the 8th. All right. Let's go back and do this one. I just want to make sure that we remember. So again, in class, if you remember that we did them all separately. So we just separated the like terms. So which gives us negative 4 over 6 times a to the 6 minus 1 times b to the 4 minus 4. So we're going to simplify negative 4/3 to, 4/6 to negative 2/3. A to the 6 minus 1 gives us a to the 5th. B to the 4 minus 4 equals 0. Now, if you're remembering from the beginning of the packet and from the beginning of the year, I've got b to the 0 power. You should be able to remember that anything to the 0 power equals 1. I hope you said 1 in your head. So it's negative 2/3 a to the 5th. And that's how our simplified answer would look. All right, so the last type that we're going to do are raising a power to a power. Please notice I've shown this answer for you, showing how we distribute this 3 to every member of the parentheses. And this 3 right here has an exponent of 1 because it's not written. That's why we end up with 3 to the 3rd, because 3 times 1 is 3. 3 times 2 is our 6, which is right here. And 3 times 5 is 15, which is right here. So let's look at what that looks like for number 15. We're going to end up with -7 squared, because we distribute here. A to the 18th, because we distribute here. B to the 6th, because we distribute here. And C squared, because we distribute there. And so then you can simplify this because you know what -7 squared is, which is 49. A to the 18th, B to the 6th, C squared. All right. I'm really sorry I blanked out your videos. You couldn't see all of it, but I hope this helps. And I hope you are continuing to do your work. And until next time, I hope you have lovely days. And I hope that everything is going well for you and your family. All right. Y'all have a lovely day.